This video will cover Chapter 6, Section 4, which is proving triangles are similar using two new methods, side, 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 and side angle side similarity. So once we get through today's, you'll now know three methods to proving triangles are similar. So the first is side, side, side similarity theorem. And it says if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So if I take this triangle that's drawn here, and I put the longest over the longest of the small triangle, which would be 10 to 5, the middle length over the middle, which would be 8 to 4, and the smallest over the smallest, which would be 6 to 3. If all three of these fractions reduce to the same, which they do, they're all 2 to 1, then I can say that all the side lengths are proportional, and these triangles are now similar. So triangle ABC would be similar to triangle DEF, and the reason is side, side, side similarity. The last or third and last theorem to prove that they're similar is side angle side similarity. So it kind of combines the two together. This says if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional, then the angles are similar, or the triangles are similar. So for this one, you need two pairs of corresponding side lengths to be proportional, like 10 over 5 and 8 over 4 would both reduce to 2 to 1. So I've got the two pairs of corresponding side lengths that are proportional, and then the angle between them, or the angle where those two sides meet, has to be congruent. In this case, angle A is marked as congruent to angle D. If those are true, then these two triangles are congruent, and it would be side angle side similarity. So let's say that you had two triangles drawn, and we had 5, 10, 6, 8. So I know from this diagram that these two angles would be congruent because they're vertical angles. And then if I put 5 over 10 and 6 over 8, they do not reduce to the same. So this would be 1/2, and this would be 3/4. So these triangles would not be similar. Another variation of that would be if the two triangles were drawn, and let's say I have 5 to 10 and 4 to 8. In this case, I still have the vertical angles that are here marked as congruent. 5 over 10 would reduce to 1/2. 4 over 8 would reduce to 1/2. But the angle that's marked as congruent is the non-included angle. So these would not be similar. There's not enough information. In order for them to be similar, this angle over here would have to be congruent to this angle over here, because those are the two sides. That's where the two sides that are proportional meet. Okay, so a couple of examples. First, this is now all three of the ways to prove that triangles are similar. Angle, angle, which we learned in the last section, side, 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 and side, angle, side, which we're learning in this section. So when you go to take your test on this chapter, you're going to see them all mixed in together. These are the only three ways to prove that they're similar. This example says the measures of the sides of triangle ABC are 4, 5, and 7. So if I drew a triangle, labeled it A, B, C, 4, 5, 7. And the measures of the sides of a triangle X, Y, Z are 16, 20, and 28. Are the triangles similar? So because I don't know anything about the angles, I know I'm going to be looking to prove that these would be similar using side, side, side similarity. So I take the smallest one and put it over, take the smallest, which is 4, put it over 16. Then the middle, which is 5, would go over 20. And then the largest, which is 7, would go over 28. Simplify each of these fractions. So this is 1/4, this is 1/4, and this is 1/4. Because all three of these are equal, the answer is yes, these triangles are similar. Triangle ABC is similar to triangle XYZ. Okay, example 2 says if triangle XYQ is similar to XZP, So let's identify those. X, Y, Q would be this triangle here, is similar to X, Z, P, which is this triangle here. Does it follow that X, P, Q, so I'm going to highlight this in a little bit smaller, X, P, Q is similar to triangle X, Z, Y? So let's split these up. Let's say that this is X, Z, P, so X, Z, P, and the other one was X, Y, Q. And so if these are similar, this is congruent to this, this to this, and this to this. And then if they're proportional, so let's say that this is, I know it doesn't look like it, but let's say that this is 2 to 4, and this is 6 to 12, and this is 8 to 16. So that would say that this 2 to this 4 would be proportional, and this large side here, the XY, we said was 12, would be proportional to XZ, which is 6. So with the angle at the top being the same, if I were to set up my ratio, I would get that this 2 over this 6 would be proportional to this 4 over this 12. So because I've got the angle at the top and then the side, angle side, I can say that these are also similar. So we just picked values for this, but any value that you would have picked would have worked that way. Example 3 says, name the similar triangles and give the postulate or theorem that justifies your answer. So let's look at these one at a time. So I've got this first one, 2 triangles. The top angle is obviously part of the smaller triangle and the large triangle. So I've got an angle, and then 80 and 80. So this would be S, and this would be angle, angle, similarity. B, this time I've got the angle at the top, that's part of this one, and the large one, so I've got one angle, but I don't know anything about the other angles. What I do have is the side lengths here. So 6 over this whole side, which would be 9, needs to be proportional to 10 over this whole side, which is 15. So this is 2/3, and this is 2/3. And because those are proportional and the angle in between, this would be S, and it would be side angle, side similarity. And C, this time I've got 3 side lengths. I don't know anything about the angles. So if I put the smaller, which is 3, over the smaller of these 3 lengths, which is 6, and then the middle length, which is 5, would go over the middle length, which is 10, and then the third side, which is 6, on the small triangle, should go over the longest side on the big triangle, which is the 6 plus the 6, or 12. All of these reduce to 1/2, so this is also yes, and it's side, side, side similarity. Okay, that's it for that section. Make sure that you take note and submit it to the assignment.